So in this video we're gonna start by setting up the solution and then showing you guys how the solution or how much lift you guys should end up with. So first let's go to Workbench and we're gonna drag results under component systems. Sorry, not results, we're gonna drag Fluent under component systems, and then we're gonna drag the mesh to the setup, and then just make sure you update the mesh. The update might take some time. After the mesh has been updated, we can open setup and make sure you turn on double precision and change the solver processes to however many logical processes you have. You can check this from your task manager, and usually for UE computers we are using 20, so we're gonna put 20 value and start. So now when the mesh is open, we want to just make sure that we're using the K omega SST model. You can see on the left here, you can either use the top GUI or on the left. I want to make sure that the models we have, everything is off except the viscous SST K omega model. We're gonna go to cell zone as well, and then open fluid, and you can see the inner, outer and rotate that we used from create and S. Double click on rotate and this should pop up something in the center, and now you can see we can edit the rotate values in terms of like airflow. Click on frame motion and make sure we change the rotation's axis direction from Z for 0 and Y is 1, so we're rotating around the Y axis, or we want to simulate the air rotating around the Y axis. And for the speed, we're gonna write negative 733.04. This is basically 7,000 RPM. So if you multiply by 2 pi, 7,000 multiply by 2 pi divided by 60, you get this. Click apply and then click close. Nothing, we don't need to do anything else. In the boundary conditions, we don't need to set any inlet velocity for now, because what we're doing right now is hover. If you want to set a different an inlet velocity, you can go to inlet and then change the value here, but for now we're gonna keep everything the same. Even we can check the gauge pressure here, keeping it at 0. You want to also show the lift and the moment. So to do that, we're gonna go to report plots under monitors, and we're gonna click on new, and we're also gonna click on new here, and we're gonna go to a force report, and this can show you the lift. Click on it and make sure we're selecting lift force, and then we're gonna make sure we're selecting blade, and we're gonna keep it at the y-axis because we do want the y-axis as force, and then just click OK. We're gonna do the same thing for the moment. We're gonna go on new, go to force report, and go to moment. We're gonna also change the moment axis to y-axis, so we're gonna make it 1 and 0 here. Click on the blade and make sure we have the report output typed moment. After you're done with that, you can click OK. So this is gonna show us the lift and moment graphs while it's running at the same time. And finally, we're gonna go to solution, and we can basically just run calculation. It will initialize by itself if we just start to run calculation. And we're gonna set the number of iterations to 1000. And if you have more numbers of iterations, the more accurate this will be. But for now, we're just gonna put 1000, and you can see here when we click on calculate, it asks us to initialize. You're gonna click yes, and we're gonna just wait until the solution starts running. And now, as you can see the lines are starting to form, and it's fine for it to start from negative. It's gonna converge back, and I will skip the video so we can basically look at it after it's done. So we've completed the calculation after 1000 iterations. You can see while I hover my mouse on the line, you can see the value for the lift being around 0.7292, and it's kind of converging around that. We can also see in terms of graphics how the velocity lines are looking like around the blade. So to do this, we go to results and we double click on pathlines, and we can also draw the mesh. You make sure the draw mesh is on, and basically just close these. Just make sure that the blade is the only one that's on, and click display, and you can see the blade being shown now. If you want to see the mesh as well, you can turn on the edges in there, but for now we're gonna keep this the same. Here in the main pathlines display, we're gonna click on steps and change it to 100, and pathscape change it to 10, and just click save display. And just to note, you can do whatever you want. You can basically look at other types of visuals, but this is just for simplicity, just to see the velocity stream. Here, this is the particle stream. This is not the velocity one, but this is just showing as an example. If you wanna, like, let's say add another path line, you can just add another one. click on particle velocity, change it to velocity, and click on the blade, change this to 100 and change the path skip to 10. And if you click save and display, you're now gonna see it, but because we haven't ticked draw mesh, it won't show the blade itself. If you want both at the same time, we can go back and edit pathlines too, and make sure the draw is on, so the draw mesh is on, and make sure that the edge is on as well. We can click display, and now you can see the mesh as well when you clicked on edges. Now if you want to also just make sure that we have the draw mesh ticked while selecting the velocity and the blade, and making sure the steps and path skip are correct, and clicking save and display. And now let's just close, and now you can clearly see the velocity path lines, and you can also see the contour on the left showing the maximum and the minimum speed. And you can see the minimum speed is at the hub, and at the tip is the maximum speed, which completely makes sense.